Okay, so essential questions for 4.6. 4.6 is going to ask you to apply everything we've been doing in the earlier sections to some more word problem formulas. You're going to have to pick the formula. So one essential question is, what are some guidelines for deciding which formula to use? And you should have a copy of the formula sheet that you'll get on the test. We don't expect you to have all of these memorized. We just expect you to know how to use them. So what are some guidelines for deciding which formula to use? And then what are some guidelines for solving the equations that come up? You'll work with equation solving techniques from 4.5. I'm sure you can already tell this, but I'm sick again, Gideon's sick again, so we'll go to the doctor today. I should be able to be back with you on Wednesday. Okay, so your objectives, write exponential models, and then in word problems, evaluate the functions and solve equations as needed. So for your first formula, it's for exponential growth, but specifically for exponential growth when you are doubling your population. So if you know that your growth is doubling every however often they're talking to you about, you select this formula and you can pick that out because it's got a 2 here to go with the whole idea of doubling. Here the n sub 0 is your initial amount. So initial population, initial amount of bacteria, whatever that may be. A is your doubling time. Well, since that's a time and t is a time, those units have to match. So if everything is in hours, okay, great. If something's in hours and something's in minutes, then you need to switch it over. The next one is for exponential growth, and it looks similar. It's a little bit differently because it's not necessarily doubling. So if that changes out and we're not necessarily doubling, then you just have to know your growth rate. And so for that, you notice that since it's not doubling, the 2 has been replaced by an E for exponential growth. The n sub 0 is still your initial amount. The R in this case is your growth rate. Most likely they'll give you a percentage. You need it as a decimal. And then the last one that we work with is radioactive decay. So half-life problems, talking about things shrinking instead of growing. So radioactive decay, M sub 0 is your initial amount, and H is your half-life. And since that's a time, the half-life and the T, those units have to match as well. Okay, let's take a look at some problems you can use your formula sheet to refer back to. A certain culture of bacterium, Rhodobacter sphaeritis, initially has 25 bacteria, and it is observed to double every 5 hours. Double is going to be your clue to use the formula that dealt with exponential growth for a doubling population. So from that, I know that I should use n of t equals n sub 0, 2 to the t over a. And n sub 0 is my initial amount, and a is my doubling time. So as I want to go fill some stuff in, the 5 hours, that's A, initially has 25 bacteria, that's N sub 0. And then pay attention in each question to what they want you to round to. You'll come back to that towards the end. Round answers to the nearest tenths place. Okay, so we have our formula. We can now fill some stuff in, find an exponential model. Well, n of t is going to equal 25 for my initial amount times 2 to the t over 5, because a was 5. So that's my exponential model, where t is in years. Sorry, t is not in years. T is in hours. So that's all I really need to do for part A. Part B is estimate the number of bacteria after 18 hours, so double check that your units are the same, which they are. So I'm just trying to find n of 18. This is a calculator question. 25 times 2, and I want the exponent to be 18 over 5. And I'm going to round to the nearest tenth, so the first decimal place, 303.1 bacteria. You should be checking these on your calculator with us. Make sure that you pause and ask a neighbor if you need any help. Okay, next question. After how many hours? So I'm trying to find a t value. Will the bacteria count reach 1 million? So I need to pay attention to what everything was measured in. So if I go back up to the top, oops, sorry. I started with 25 bacteria, so it wasn't like 25 million. I just started with 25. So I'm wanting my n when I'm done to be 1 million, and I need all the zeros. Okay, so I'm trying to solve the equation 1 million equals 25 times 2 to the t over 5. And this makes me go back and review 4.5. I need to know how to do 4.5 to be able to do this. I need to get my exponential part by itself, so divide by 25, divide by 25. Do not round until you are done. So this cleans up nicely to be 40,000 equals 2 to the t over 5. Sorry, my pen is not working very well. And then I want to solve this. It's exponential. I would take a look and decide if I can make the 40,000 be 2 to the something, but not easily, not off the top of my head. So I'm going to switch over and do log form. And this was from 4.5. So it would be log base 2 of, and you need to decide, ends up being of 40,000 is equal to t over 5. And you can check with the arrows if that makes sense. 2 to the t over 5 equals 40,000. And my last step is I want to solve for t, so I need to multiply this by 5 so they cancel. I need to multiply this by 5. So my exact answer is that t is 5 times log base 2 of 40,000. But I'm going to put that in my calculator and get a decimal rounded to the first decimal place, the tenths place. You should be getting 76.4. And you need to make sure you know what you're measuring. This is time, and if you go back up and take a look, it was in hours. So 76.4 hours. Okay. Next, certain species of bird was introduced, and it's again talking to us about doubling. So if it's talking to us about doubling, I'm going to use the formula that n of t is equal to my n sub 0 times 2 to the t over a. And you can use your formula sheet to get that. If I go back up and plug some stuff in, 25 years ago was when this was introduced. So that means that I'm thinking about when 25 years ago, sorry, that's when I had my n sub 0, my initial population. But then they're telling me that now I have 13,000. Well, now means that t is 25 and that n that comes back out is 13,000. So same kind of formula, but they're asking us to use it differently because they're giving us different information. It doubles every 10 years. So doubling every 10 years means that A is equal to 10. So I can start off with n of t equals n sub 0, which I don't know, times 2 to the t over 10. And then I can plug in information to figure out n sub 0. So when t is 25, I know that n is 13,000. Oops, sorry. So I put 13,000 in here for n. I'm trying to find n sub 0, but I will know that that's equal to 2 to the 25 over 10. Okay, well that's just a number, 2 to the 25 over 10, 2 to the 2.5. I'm going to divide that on my calculator to figure this out. You should do this with us. You should get out your calculator and divide and make sure that you're accurate. So 13,000, sorry, that's a comma, over 2 to the 25 over 10. That's going to equal n sub 0. And if you go read, it tells you to round to the nearest whole number. So in your calculator, you should be coming up with 2,298 bacteria. If you're not getting this, pause and look at your neighbors and see if you can help each other. So now they want the population 5 years from now. Well, now was when t was 25. So 5 years from now is when t, is 30. So update your formula. You now know from doing part A that n of t equals 2,298 times 2 to the t over 10. And now you want to find n of 30. And that's a calculator question. So again, get out your calculator and check that you're okay. You should be coming up with 18,384 bacteria. If you need any help on this one, because it was a little different, pause and talk to your neighbors at your table. Okay. Next one, we're looking at a population of fish, but they don't tell us that it doubles. They tell us that the growth rate is whatever. So that tells us that we're going to use n of t equals, and we're going to do the exponential one with e, n sub 0 e to the rt. So knowing the growth rate of 1.2%, I know that r is point, and you want to move it over as a decimal, 0.12. It's estimated that the population in 2000 was 12 million, and then if you read the question, they want you to measure after 2000. So in 2000 is when we're starting our time. In 2000, you know that n sub 0 was 12 million. You know that this population is growing, and you're already starting with something in the millions. I would just use 12 in your formula then. Hold on a second, sorry. Okay, excuse me. Alright, so I would just use 12 instead of all those zeros this time since you're already starting in the millions. So then I can fill in, so n of t is equal to 12 for the 12 million, e to the 0.012 times t. And then we need to make some notes that n is already in millions, so I don't need all those zeros. And then t is the years after 2000. So then they want me to use my rule to estimate the population in 2005. So that would mean that t is 5. So I'm trying to find n of 5. That's a calculator question. 12 times e to the 0.012 times 5. And it says round to the nearest thousand, so keep 3 decimal places. Oh, sorry. Yeah, keep 3 decimal places. So 12.742 million fish. Really what that is, if you need to expand, you would have to move that decimal place over to account for the 6 zeros. So you would move it over 6 times and get 12,742,000 fish is what that means. But it's totally fine since you wrote your model in millions to leave it 12.742. After how many years will the population reach 14 million? So I'm trying to figure out t, and the 14 million means that the n that's coming out is 14. I don't need all those zeros because I wrote my formula in the millions. So going back up to the blue formula that we have, I'm trying to solve when 14 equals 12 e to the 0.012 times t, and I'm trying to figure out my time. This is a 4.5 question. So I want to get the exponential part by itself, so I want to divide by 12 and divide by 12. I do not want to round at this place, so I'm going to leave 7, 6. If I round this early, my final answer won't be accurate. And then I need to switch this into log form. And you should know that log form for an e is natural log. So natural log of 7, 6 is equal to 0.012t. And you can check that e raised to the 0.012t is equal to 7 over 6. And then your last job is putting this in your calculator, dividing by 0.012. Dividing by 0.012. Get out your calculators and do this with us to make sure you're good on all of the parentheses involved. So you should be coming up with t being approximately 12 point, and let's see what they wanted us to round to, tenths of the first decimal place, 12.8 years. And that technically, to understand what that is 12.8 years after 2000. So almost in 2013, towards the tail end of 2012. last one, the half-life. And seeing that you're dealing with half-life tells you should be working with the m of t formula, where it equals m sub 0, 2 to the negative t over h. The half-life of cesium-137 is 30 years, so 30 is going to be equal to my h. Suppose we have a 10-gram sample, so 10 is going to be equal to my m sub 0. Find a function that models this, so m of t is going to equal 10 times 2 to the negative t over 30. And I should specify that t is in years. Okay. How much of the sample will remain after 80 years? So I can plug in that t is 80, and this is a calculator question. 10 times 2 to the negative 80 over 30. Yep. And so in your calculator, rounding, if you go back up and take a look, rounding to the nearest tenths, so just to one decimal place, you should be getting 1.6. So 1.6 grams. Then the last one, after how many years, so in this case I'm trying to find t, will there only be 2 grams left? So that's when I want m to equal 2. So going back to my initial equation, 2 needs to equal 10 times 2 to the negative t over 30, and I'm trying to find this t value. This is a 4.5 question. You have to know how to solve equations. I need to get my exponential part by itself, so divide by 10, divide by 10. 2 tenths is the same as 1/5, so I'm going to leave that. I'm not going to round right now. 1/5 equals 2 to the negative t over 30, and I'm going to switch it into log form. So the base of my log is 2. I'm going to take log base 2 of 1/5, and I'm going to get negative t over 30. So then I'm going to multiply by 30 here to cancel. I'm going to multiply by 30 on the other side to balance. And my last job is seeing that I have this negative here with the t. Hold on for a second. Alright, sorry. So I don't want this negative to be up here, so I'm also going to multiply both sides by a negative 1, so that will counter this negative that's already here. So I will end up getting that t is equal to negative 30 times log base 2 of 1/5. Put that in your calculator, and you should be coming up with, if we go back up and look, they wanted us to round to the tenths place. So you should be coming up with 69.7 years. It seems weird that this negative is going to be our solution. It seems like I'm going to get a negative number back out. But if you go back and you take a look at log graphs, let me switch over. Your basic log graphs go through the 0.10 and they curve like this. They have that vertical asymptote at x equals 0. And so if I plug in a fraction value for my x for a log, I should be coming up with a negative value already. So that negative in combination with the negative 30 gives me an overall positive answer. Okay. Please make sure you go back to any of these and compare with neighbors as far as how you get answers on your calculators, because there's lots of parentheses that you need to pay attention to in order to get these right. When I come back with you on Wednesday, I'll take your questions and then we'll quiz on this and see how you're doing. Your assignment is as listed on the sheet. You will get your formula sheet on the quiz and on the test. It just won't have any more information than it does right now. So with the sub handed out to you, that's what you will get access to on the quizzes and the tests. If you have any questions, come see me Tuesday morning or Wednesday morning in room 105, or stay after school in the library for help from a math teacher. Sorry I couldn't be with you today.